All right, so in the last video, we went through and we looked at an example where we went ahead and we used the pushback function to actually fill the vector. All right, and this completely works. We made our vector up here, right? And we don't give it a size because we don't do that with vectors. Later on, I use the pushback function and I basically add on every number that I'm entering onto the end of that vector. And like I said, this works just fine. But the problem with it, what makes this inefficient is that every single time we're adding on, we're resizing that vector. And like I said in the last video, the computer is putting aside a certain amount of memory for this vector. Well, if we exceed that amount, what it's going to do is it's going to copy the whole vector in a new place where there is no more memory available. Well, copying that whole vector is very inefficient. And it's why, typically if we don't have to use vectors, we don't want to. But there are some ways we could possibly avoid that, namely not using the pushback function when we don't need to. So let's look at how we could do this without needing to use that pushback function. So the first one is to use the resize function. So just like before, I'm going to go ahead and I'm going to ask the person, okay, how many numbers do you want to put in? Basically, how many numbers do you want to take the average of? And then I create the vector right here. I'm going to call it numbers. And then I'm going to resize the vector immediately to make it the size that we want it to be. And so now when I go through and I add numbers in, so in my loop down here, I'm just asking the person, okay, start entering your numbers, and we put them in to the vector one by one, just like that. Okay, we do our cin into our vector, and we do it one by one. Now it's not resizing the vector. It has already put aside enough spaces. So if they said they want to enter 5 numbers, it's just going to go ahead and it's going to set aside 5 blocks of memory, right? And since these are ints, it's like 4 bytes, I think, or something like that. But anyways, 5 spaces in memory to hold the integers, all right? And so when we put the numbers in, it's never going to have to resize this because that is already set aside. And so that's very useful in a case like this where once the user has chosen how big they want the vector to be, we don't need to resize it ever again, all right? And so, this is going to be much more efficient than the other way. The other way, there are times when you have to use the pushback function. But if I know how big the vector is going to be when the person tells me how big they want it to be, I'm just going to use the resize function. I'm going to make it the correct size at the beginning, and then later I'm going to put in numbers, just so that I don't end up having to resize the vector later on when I'm adding in numbers. So it doesn't have to take that vector and copy it into a new place when it runs out of space. It will already have put enough space aside. The other way we could do this is using the assign function. So remember, the assign function takes and it fills the entire vector with a value. Now, I would not do that for this particular program, but there are times when you have to do that. So again, I'm creating my vector right here, right? I ask the person, okay, how many numbers do you want to create? Or how many numbers do you want to put in? And then I have them, and then I create the vector right here. And then I'm going to use the assign function right here again, because that is going to tell me how big I want the vector to be. And in this case, I have to say how many things I want or what I want to put in there. So I'm going to fill it with zeros. All right, so again, this gives the vector a size at the beginning, and I won't have to resize it later on. Now, why would I not want to do this particular thing for this program? Well, later on, I'm going to fill that vector up with values anyways, so there's no reason for me to use assign and fill it with zeros in there, all right? In this case, I would just use the resize one just to make it the correct size, but I'm not going to put values in there if I don't have to at the beginning, right? If I'm putting values in later on, there's no reason to put values at the beginning. But there are many instances where you will want, when you create your vector, you'll want to fill it with numbers right away. You'll maybe want to fill it with zeros or something else. And that's when you're going to be wanting to use the assign function. All right? So that's 3 ways to do this, some more efficient than others, and all have their place, right? The push back function definitely is important. If you don't know how big that vector is going to be, yeah, the push back function works great because you just keep adding numbers on the end. The resize button, or the resize function, if you know how big that vector is going to be, yeah, use the resize function to set it to that size. And the assign function, if you know how big it's got to be and you want to put values in, right, that assign function works great, right? And that's kind of everything with the vectors. So at the end here, I just wanted to talk about, okay, vectors versus arrays. Like, when would we want to use each of them? Well, the first thing, and I think kind of the most obvious thing, is like, well, arrays, we can't change the size. And the user or a file input can't tell us how big that array needs to be, okay? And so, arrays are very limiting in that aspect, right? They have a set size, and they got to have that set size when you compile the function, right? Whereas vectors, they give us flexibility. We can change the size. We can have the user change the size. We can take a number from a file and have that change the size. It gives us a lot of flexibility in that case, all right? But that doesn't mean we should always be using vectors. We actually should avoid using vectors a lot of times if possible, because the problem is that vectors can be really inefficient. So when we set an array, basically, let's say we set an array that was, I don't know, we needed to put aside 3 places for integers. It's going to take those 3 places, it's going to set them aside, and it's going to set them aside, and that's where the array is going to be forever. So think of this all as our memory right here. It took these pieces of memory, set them aside, that is our array. And that is forever where our array is going to be. It's never going to change. But like I said, with a vector, let's say it set aside these 3 pieces, but then later on we needed this vector to be size 4, right? We needed it to add an extra one on the end. Well, it's not just going to add it onto the end there because it doesn't know if this piece of memory is available to it. What it's going to do is it's going to find another place where it can go ahead and make the array bigger. So, maybe if we needed it to be size 4, it would maybe pull 6 pieces aside, something like that, and then it deletes the old one. That's really inefficient. That's really CPU and memory intensive to do that, to take this transfer and copy it over to a new place. And so vectors are great, but they can be CPU and memory intensive. And so, that's kind of the idea. If we don't need to change the size of our array, we're just going to use arrays. We're only going to use vectors when we absolutely need that functionality. All right, so that's kind of the introduction to vectors. Please let me know if you have any questions and get working on program 24. And yeah, that's basically it.